video on the winter method. In the first one, we did all the seasonality adjustments. Here are the average seasonalities for each day of the week. And I've also included the alpha, beta, and gamma that we use in the smoothing functions. So let's estimate our first level, the level of period 1. We don't have any new information, so we will basically use the data from our regression. So we'll take the regression, so the level at point 0, plus the trend, and we have our level of period 1. The trend in period 1 will be the trend we had in the regression. Now with those two figures, you can already forecast period 2. So period 2 will be the level plus the trend, and to adjust for the seasonality, we multiply that by the previous seasonality of the corresponding period, Tuesday. Okay, and we have a forecast of 424.8 compared with the actual figure of 430. Now let's make the adjustments at the level, the trend, and the seasonality using the smoothing constants. Adjusting the level, the actual level is the demand divided by the average seasonality. So we bring that demand to the baseline demand, multiply that by alpha, plus the previous level. The previous level was the previous forecast would be that, plus the trend multiplied by 1 minus alpha. This is very similar. It's actually the same as we did for the halt, with the exception that we are now dividing the demand by the seasonality to bring it all to the baseline demand, and in the halt we use directly the demand. So that gives us a new level. And what will be the new trend? The new trend will be the actual trend. Actual trend is simply that level minus the previous level. We multiply that by beta plus the previous trend that we had multiplied by 1 minus beta. Okay, again, actual trend multiplied with smoothing constant, previous trend, 1 minus smoothing constant, exactly the same we did for the halt. And well, we can already forecast period 3, right? But let's first adjust the seasonality. What is the actual seasonality? The actual seasonality is the demand divided by the baseline demand, the level. So we multiply that by gamma plus the previous estimate of the seasonality was our average seasonality multiplied by 1 minus the gamma. Okay, so we are now adjusting the seasonality to our most recent observation. And it was slightly different from that one. Let me just put all these numbers. I will adjust that to a few more digits. Now, before we copy all these formulas that we are basis, we need actually to do the same for the seasonality for Mondays that we started here. So I'll just first copy that to here, because that will be used later in the formulas. And then I will copy all these 4 formulas down to all our observations. And we have our forecasts. The challenge now is to make the forecast for the future period, this part here. We won't be able to adjust anymore because we don't have any new data. So what we'll do with our levels and trends, our new level will simply be the previous level plus the last trend. I will fix that because I want to do that for all the, and I can copy. So these are new levels. You see that we are forecasting a straight line with a negative trend, as we see, and these trends will be exactly the same as here, so no difference. So I'll just copy and so, and here we can simply copy and we have our forecasts. So it's all done, and if you look at your chart, we will add that forecast, select data, and I will add a new forecast, selecting that series here. I will start here to make it match. And look like that. It's really amazing how the method can forecast the exact profile that we see in the past few cycles. What is left? What you could do, you could optimize this alpha, beta, and gamma if you measure the errors and find the best values of alpha, beta, and gamma to minimize your errors. But that's the mechanics of the wind turbine. Hope you learn, practice, and try to understand the technique and apply it in several exercises.